Okay, let's dive right into this. If you're a senior architect these days, you're not just managing one cloud anymore. You're basically conducting an orchestra of them. And the biggest challenge? It isn't just getting them all to play together. It's making sure they play a reliable tune for your users every single time. So today, we're going to break down exactly how you architect that reliability and tame all that complexity with a really powerful tool, the SLO tree. And this question right here, this is the high-stakes reality, isn't it? That promise of 99.95% sounds so simple on paper, but when your actual infrastructure is this sprawling ecosystem spread across AWS and Azure and GCP, well, it's anything but simple. A little hiccup in one corner can trigger this massive cascade you never even saw coming. So for real, where do you even begin to untangle that web? Okay, don't worry, there is a method to the madness. We're going to walk through it. First, we'll tackle the puzzle itself. Then we'll learn the language of reliability. After that, we'll unpack the core strategy, which is all about decomposition. Then we'll actually build an SLO tree step by step. And finally, we'll see how to put that tree into action. First up, let's really get our heads around the complexity of this multi-cloud puzzle. It's all about going from that one single promise you make to your user to really understanding the huge, interconnected web of dependencies that has to deliver on it. I mean, just think about it for a second. When a user clicks login, they just expect it to work. That's the one promised. But behind the scenes? Whoa, that one click might hit an API gateway on Azure, which then calls an authentication service over on AWS, which then turns around and queries a user database sitting on GCP. Your one simple promise is actually this whole chain of dozens of hidden handshakes between different cloud providers. So, to manage all this complexity, we need a common language. We can't just talk about things being up or down. That's not good enough. We need to be precise. And that's exactly where service level objectives, or SLOs, and their best friend, error budgets, come into play. So what is an SLO, really? Well, think of it like your internal North Star for reliability. It's a super precise target, like 99.95% availability over a 30-day period, that your engineering and product teams all agree on. Now, what's absolutely crucial here is that this is an internal goal. This is not some contract with a customer. This is how you measure yourselves. And this leads to one of the most powerful ideas in modern engineering, the error budget. See, if your SLO is 99.95%, your error budget is that leftover 0.05%. And what does that mean on a Tuesday morning? It means the whole conversation changes from, whose fault was the outage, to, are we spending our error budget wisely so we can innovate faster? It's a huge cultural shift away from blame and towards calculated risk. Now, let's be crystal clear about something. An SLO is not an SLA. An SLA, a service level agreement, that's your external contract with customers. If you break it, you pay penalties. An SLO, on the other hand, is your internal target. If you're about to burn through your error budget, it triggers an internal response, maybe a code freeze. We are focused on SLOs. That's the tool for architects. Okay, so we've got the language of SLOs and error budgets down, but how do we apply it to a system that's just a tangled mess of dependencies? Well, the key is a total mental model shift. We have to stop seeing our application as one giant, mysterious black box, and instead start seeing it as something more like a reliability family tree. And this right here, this is the absolute turning point. You just can't manage what you don't understand. As long as your system is just this big monolith in your mind, you're just guessing. Decomposition is the act of breaking it down, service by service, dependency by dependency, until you have a crystal clear map of how reliability actually flows through your architecture. All right, let's get practical. Enough theory. It's time to actually build one of these SLO trees. I'm going to walk you through the whole process, step by step. Everything, and I mean everything, starts with the user. What is the single most important journey you need to protect? Maybe it's user login. Maybe it's adding an item to a cart. You pick one and you define an SLO for that specific journey. That right there becomes the root of your entire tree. It's the promise that everything else has to support. And notice how simple this is. We're starting with just one box, user login, 99.95% reliable. This is our anchor. You can almost think of it as the matriarch of our little reliability family tree. Every other component we're about to add, its entire purpose is just to hold this one single promise up. So next, you ask a really simple but powerful question. For a user login to actually succeed, what services absolutely have to be working? You're not trying to map the entire universe here. You're just identifying that first layer of direct critical dependencies. And bam, just like that, our tree starts to grow. That single user promise immediately splits. We can see right away that the login depends on an API gateway running in Azure and an authentication service running in AWS. The multi-cloud complexity is instantly visible. Now, this process is recursive. You just do it again. For every new service we've just added to our tree, we ask the exact same question. For this service to work, what other services have to be working? We just keep peeling back the layers of the onion. And this is where you uncover the really interesting stuff. We see our auth service on AWS actually depends on a user database that's running on Google Cloud Platform. How about that? We've just mapped a critical path that literally snakes its way through all three major cloud providers, a potential single point of failure that was completely invisible just a minute ago. And finally, you assign SLOs all the way down the tree. Now here's the golden rule. Each dependency must have a more stringent, a tighter SLO than the service that relies on it. So if your user login needs to be 99.95% available, its dependencies might need to be 99.99%. You're basically building a pyramid of reliability from the ground up. So we've built the tree. It looks great on a whiteboard, right? But what's the real payoff? Well, this is where our diagram stops being just a diagram and transforms into a powerful, day-to-day diagnostic and decision-making tool for the whole organization. Your abstract tree turns into a concrete, living dashboard, something just like this. And look at that AWS auth service. Its 99.99% SLO isn't just a number anymore. It translates to just 30 seconds of acceptable downtime left for the entire week. That is the kind of hard data that stops a risky deployment in its tracks. It turns reliability from some vague goal into a tangible, minute-by-minute resource your teams can actually manage. And once you have this in your hands, you move from just guessing to actually knowing. You can now pinpoint exactly where your system is most fragile. You can have real, data-driven conversations about trade-offs, like should we spend our time hardening the database or that auth service? And you can finally justify infrastructure choices and put your best engineers on the problems that truly matter. So, I think the crucial point is this. Reliability isn't some mess you clean up after an outage. It's not something you just fix. It is a fundamental property of your system that you have to proactively design and architect from the very beginning. And the SLO tree, that's your blueprint for doing just that. And that really leaves us with one final question to take back to your own teams. Once you build your SLO tree, it's going to tell you a story about your dependencies, your assumptions, your blind spots. The only question left is, what story is it telling you about your biggest risks?